I am Ennemcien. We were studying simple harmonic motion basics, and we have seen two kinds of equations. One is the differential equation, that is acceleration equals minus a constant into displacement, or in differential form it is d square x by dt square equals minus omega square x. Here the vibrations are assumed to take place along the x-axis. If the vibrations are along the y-axis, we will write this equation as d square y by dt square equals minus omega square into y. If it is along the z-axis, the differential equation is d square z by dt square equals minus omega square into z, and so on. Now, then we have seen two displacement equations or analytical equations. One is x equals a sin omega t. The other is x equals a cos omega t. Now, our next step is to find the most general equations of simple harmonic motion. You must be familiar with it. And this is the most general form. X equals small letter a sin omega t plus b cos omega t. If the displacement equation is in this form, amplitude of the vibrations is given by capital A equals square root of a square plus b square. And we can simplify this equation in the form x equals a sin omega t plus phi. This phi is the epoch. This can be calculated using this formula. Phi equals tan inverse b by a. You will see the application of this equation. Next point is velocity of simple harmonic oscillator. I am introducing only the formulae, not the derivations, that you will get from this your school or any other books. You will get it. We are interested in formulae, concepts, and problems. This is the expression for velocity of simple harmonic vibrator. V equals omega into square root of a square minus x square. This is the expression for velocity when the oscillator is at a distance x from the mean position or resting position or midpoint. When the particle is or oscillator is at the mean position, we will take x as 0. Now the velocity v is a maximum given by v maximum equals omega into square root of a square minus 0 square, or v maximum equals omega into a. Next point is kinetic energy of the oscillator or vibrator, that is given by half mv square. So this is half m omega square into a square minus x square, or m omega square is nothing but k, because omega square is k by m. Therefore m omega square is k. So you can rewrite the expression for kinetic energy as E kinetic Ek equals half k into a square minus x square. And the maximum kinetic energy is when x equals 0, that is when the oscillator is at its mean position. And the maximum kinetic energy is given by Ek maximum equals half m omega square a square, or m omega square is k. So Ek maximum is half k a square. Now potential energy. This has got potential energy because restoring force is a conservative force. I will discuss it later. Within a few postings, I will discuss it in detail. So every conservative force is associated with with potential energy. We will study it. Our potential energy expression is given by EP equals half m omega square x square, or m omega square is k, so potential energy EP equals half k x square. And maximum potential energy is when x is maximum value of x is amplitude A. So EP maximum equals half k a square. Thank you.